Hello students, today's topic in the subject of industrial electronics would be power BJT, or we can say first as power transistors. Now power transistors can be power BJT, power MOSFET, then IGBT, which we will discuss as types of power transistors. In these types of power transistor, the first topic is power BJT. Now, a power BJT should have or are used to handle large current and large voltages. As they handle large power, so the transistors have to dissipate a large power in the form of heat. So the size of power transistors are larger than that of low power transistor. This is very important for dissipating more power. Now, they offer high voltage resistance in off state than normal BJT and high current handling capacity in the on state than a normal or low power BJT. That is, the power bipolar junction transistor is supposed to block a high voltage in the off state and have high current carrying capacity in the on state. In order to have these characteristics, the power bipolar junction transistor must have a very different structure than a small low power BJT that we will study later in the video. Due to this modified structure, the IV characteristics and the switching behavior of power BJT will be significantly different than its logical counterpart. Now it has vertically oriented structure as mentioned before in power diodes as well. I've told you that all power devices should have vertical structures. Now, same is the case with power BJT. Why vertical structure? That we have discussed or we will be discussing in the later stages of the video. Now, the last point is high gain is to be maintained by enhancing the doping level of emitter several times than that of the base. Now, how it will help, how the doping level, change in the doping level of the emitter helps in power BJT, we will understand when we realize the structure of a power BJT. Now, symbol of power BJT is given here. Now, as we know, as the normal case or a low power BJT is, it's of two types, that is a NPN transistor and a PNP transistor. Now, for NPN transistor, the base is P-type and the collector and emitter are N-types. As we know, current passes from P to N, so here the current will flow from base to emitter, and so the sign is, or the arrow suggests the flow of current in the NPN, which is outwards. And here the majority carriers are the electrons. Similarly, for a PNP transistor, the arrow is inside, that is flowing from emitter to base, because here base is N-type and collector and emitter are P-types. Here the majority carriers are the hole. As we know, electrons have more mobility than holes, so NPN transistor is used in practice. more commonly than our PNP transistors. Now, types of power transistors, as I've told in the beginning of the lecture, is power BJT that we are studying today and most commonly called as power transistors. Then we have power MOSFET, IGBT, and state induction transistor, which we will be studying in the later stages. Today we begin with power bipolar junction transistor. Now we know a transistor is to be used as a switch. So here, and the main application of power BJT is switch, and which is used in common emitter configuration, in which control signal has to be given to the base to control the collector current, because here emitter is common and we give the control signal to the base in order to control the collector current. Now here, cutoff means off state, as we know, and I am here considering the fact that I've also mentioned in the previous video that we all know the basic theory behind a normal or low power BJT. Now we know cutoff is the off state and the saturation region is the on state. Now for a low power BJT also we know that IC by IB is the beta, where beta is almost approximately equal to 10 to 12. If this is the case, then for controlling a collector current of say 1000 amperes, the IB will be required as 100 amps, because IC by IB is beta, which is say approximately 10. So for IC to be 1000, we need IB to be 100 amps, which is very large. It is 1000 by 10, that is 100 amps, which is very large. That is, we have to have a very complex gate driver, which is what is a gate driver? Gate driver is the controlling unit that will control the IB, which again will control the IC. That is the external circuitry to control IC. If we have to have 100 amps of IB, then the gate driver circuit is very complex. So how do we take care of this whole thing? That is, how can we have an IC of larger value without complexing the gate driver circuit? That also we will study here. Now this is the structure of a power BJT. Now a power transistor has a vertically oriented 4-layer structure of alternating p-type and n-type layers with doping similar to the NPN transistor. It also has the 3 terminals, the collector, base and emitter. Now see here, all the regions are given. The NPN transistor, in which base is positive and collector and emitter are both negative. NPN transistor, as I have mentioned, are more commonly used over PNP transistors. Now the doping level in each of the layers is given here. The N positive, again that means it is a highly doped N region which forms the emitter, which has a doping concentration of 10 to the power 19 per centimeter cube, and which is almost 10 micrometer wide. And then comes the P-type region, which is forming the base of the NPN transistor, which has a doping concentration of 10 to the power 16 per centimeter cube, which is again 5 to 20 micrometer thick. Now comes the collector drift region, which in case of our diode was the drift layer. This is similar to that region, which is the lightly doped N region having a doping concentration of 10 to the power 14 per centimeter cube and is 50 to 200 micrometer wide. Now, as mentioned before, in power diode, this layer, the base layer, has to be wide in order to have a higher breakdown voltage. Previously, in low power BJT, the base region used to be lower, used to be small, because we know the recombination has to be less. Here the base region is more because we cannot afford a smaller base region, because we cannot afford a smaller breakdown voltage. This criteria has already been mentioned in our power diode. Then comes the collector region, which is again a highly doped N-type region with a doping concentration of 10 to the power 19 per centimeter cube and which is 250 micrometer wide. Now, why the vertical structure is used? The reason for using the vertical structure is that it increases the cross-sectional area through which the device current flows. And this will reduce the on-state resistance, which will again reduce the on-state power dissipation that is taking place in the transistor. That is, it maximizes the cross-sectional area through which the current in the device flows and also minimizes the on-state resistance, which minimizes the power dissipation. Now, the vertical structure also minimizes the thermal resistance of the transistor and has a large, because it is vertical in structure, it will have a large metallic body which will help in dissipating heat efficiently. As mentioned before in the starting of the video, as a BJT or power BJT handles a large power, it needs to dissipate heat, and as it has a vertical structure, it will have a large metallic body which will dissipate heat efficiently. Now, as mentioned earlier, the base region cannot be decreased to small value because it will again decrease the breakdown voltage capability. So the base region has to be increased. Now, if base region is increased, means recombination of P and N types or electrons and holes will be less. If recombination is less, then beta is less, beta is reduced. Previously, we had to, in low power BJT, we had to decrease our base region so that recombination is more. Now, if recombination was more, beta was increased, but here recombination is less due to higher base region. If recombination is less, then beta is also less to the range of 5 to 10. Now, if beta is less, then how would we get a higher IC? In order to get a higher IC, we need to have a higher IB, that is the base drive requirement increases. That is, the circuitry has to provide a larger base current which will become complex as mentioned before. Then how do we get a higher beta? how do we get a higher beta? So in order to get a higher beta, what we do is we go for monolithic Darlington pair, where beta is equal to Darlington pair. When we are talking of pair, means we are talking of two BJTs combined together. Now, if two BJTs are combined together in a particular way, then the combined beta is equal to beta 1 plus beta 1 into beta 2 plus beta 1 plus beta 2. That is, we are increasing the beta, that is, we are increasing the beta of the total combination. Now, how are these two BJTs paired in order to form the Darlington pair? So this is so that the base drive requirement decreases. Now, this is how two BJTs are connected in order to get the required higher beta. Here we can see there are two BJTs in the structure as well. In the left hand side, we see the two BJTs are combined together. Now here IC, the total IC will be IC1 plus IC2. Now IC1 by IB1 is beta 1, that is the current amplification of transistor Q1, and IC2 by IB2 is beta 2, that is the current amplification factor of transistor Q2. Now IB2 is equal to IE1, and is here you can see by the combination, that is IB2 will be equal to IE1, and IE1 is again equal to IB1 plus IC1. So we have, in case of IC1, we can write beta 1 IB1. So we have IB2 is equal to 1 plus beta IB1. Then again, if we put it, IC is equal to IC1 plus IC2, that is our first equation. We replace IC1 by beta 1 IB1 and IC2 by beta 2 IB2. Then IB2 again is 1 plus beta into IB1. We replace IB2 by 1 plus beta into IB1. So what we get is beta 1 plus beta 2 plus beta 1 beta 2 into IB1. So here IC by IB1, which is the base current of the Darlington pair. IB1 is the IB of the total combination. So here IC by IB is equal to beta 1 plus beta 2 plus beta 1 into beta 2, which is the total beta of the Darlington pair. So now for example, say if beta 1 was 10 and beta 2 is 10, the whole beta is now 120. We have increased beta. So current amplification factor increases, so base drive power requirement decreases. We do not need to have a complex circuitry to provide a larger IB in order to have a larger IC. But the disadvantage is both the BJTs are driven into hard saturation. What is hard saturation? We will study in the next class. Let us end the discussion today. In the next class, we will study about the characteristics of a power BJT.